Okay, so for today we're gonna do problem number 1 of AP Calculus BC 2021 first one questions. So like I actually did this and but I forgot to, but I somehow make a mistake on recording, which make it that didn't record. So this is what I done. So I'm gonna go over and explain how I do this. So number 1, use the data in the table to estimate the derivative of f at 2.25. So basically we just gonna, so the average, the rate of change of f at 2.25. So we use f as, so find the average, the value at between 0.2 and 2.5. So we got this. So this f of 2.5 minus f2 over 2.52, and we got 8 milligram per centimeter squares. And using the correct unit, interpret the meaning of your answers in the context of this problem. So at r equal 2.25, the density of the bacteria population in the dish increased at a rate of 8 milligram per centimeter square. So for B, we are approximating the total mass using a right-hand Riemann sum with the function n. So because it is right-hand, so we're gonna use the right values. That's the things bounded to. So like the bounded right. So we're gonna use this value, this value, this value, and this value. And also remember, the integral of the integral, we are not calculating the integral of just fr. We are calculating the integral of r multiplied by fr. So we have to be careful right there. Okay, so this is my integral to 2 pi integral from 0 to 4 of r fr dr equal 2 pi on the side. And this 2 is from r times fr. So like, because we are using when r is equal to 1, so like 1 times f1, which is 2, so it's 2, and the 1 is just the displacement, 1 minus 0. And I do the same thing for the rest. I plugged this into your calculator and I got 8.845.088. Okay, let's just do one more. So fr, so r in this case is 2, so f2 is 6, 2.6 is 12, and 1 is the change. Okay, so C is the approximation function. Part B is an overestimate or an underestimate of the total mass of the bacteria in the dish. Explain my reasoning. Okay, so this is a overestimate because we use the right Riemann sum to calculate, and also f is an increasing function. As you see, f as r is increasing, fr is also increasing as well. So for D, the density of the bacteria in the dish from 1 to 4 is multiplied by the function g defined by gr to minus 16 cosine of 157 square root of 3 altogether to the power of 3. So they are asking for what value of k. K is from 1 to 4 equal to the average value of gr on the interval of 1 to 4. Okay, so I go ahead and write down the average value of gr from 1 to 4 and plug it into calculator. I got 9.876. So we are finding a value of k, so that gk is equal to 9.876 2.876. So what we're gonna do is we're gonna draft these two equation. GR equal to minus 16 cosine of 1.57 square root of r to the power of 3, and the equation gk and the line gk at equal 9.876. We are gonna all draft these two equations into the calculator and find the x-intercepts, which is going to be our k value. And when I finish drafting it, the k value is 2.49706. Yep, and that's it, how we do it.